Last October, we featured a story about the increased use of unmanned aerial vehicles, or drones, that are being put to work in mining operations. We showed you various types of these UAVs, most of which are used at surface mines. Now, there are a few models that are designed to operate in certain underground environments, like this one, but it's challenging to fly drones underground, as you might imagine. You have to deal with confined space, reduced visibility, air velocity, dust concentration, and the lack of wireless communication systems. What about flying a UAV in an underground coal mine? Seems like that could be especially problematic, right? It presents a whole different set of challenges, starting with the lack of an available and permissible platform. In other words, drones can't really be safely flown in coal mines yet. My story this month is about two gentlemen in New Mexico who are working on a solution for solving that problem. They're going to tell us all about what they're doing right now. Meet Dr. Pedram Roghanchi. He's an assistant professor of mineral engineering at the New Mexico Institute of Mining and Technology, also called New Mexico Tech, in Socorro. And this is Dr. Mostafa Hassanalian. He's an assistant professor of mechanical engineering at New Mexico Tech. Together, they're working on an important project that could change everything we know about using drones or unmanned aerial vehicles in coal mines. MSHA currently doesn't permit drones in coal mines, or at least their components. It's all about safety.
For underground coal mines, any equipment, any electrical equipment that goes underground should be permissible.
Permissible. In the case of drones, this means
the equipment that we send underground, it should be either intrinsically safe or explosion-proof.
Check this out. The Code of Federal Regulations. Title 30, Mineral Resources. Volume 1, Chapter 1. Subchapter B, Testing, Evaluation, and Approval of Mining Products. Part 6, Testing and Evaluation by Independent Laboratories and Non-MSHA Product Safety Standards. Part 18, Electric Motor-Driven Mine Equipment and Accessories. And Subpart D, Approval of Machines Assembled with Certified or Explosion-Proof Components. Currently, only MSHA's testing may be considered to determine if electric equipment is permissible. But this could change. The agency is reviewing comments to a proposed regulatory revision right now, which would streamline the testing and approval process for equipment permissibility in underground mines. MSHA might decide to adopt voluntary consensus standards from internationally recognized bodies for permissibility testing. Alternative tests could then be used to gain certification and approval, bringing the latest and best available technologies to create safer mine environments. This would be a very good thing because it would essentially mean making miners safer sooner. Drone technology is new and still changing rapidly, so it's not specifically mentioned in the regs yet. But if a drone motor or battery should generate a spark in an underground coal mine where there's any methane gas, for example, well, you can imagine the problem. Roghanchi and Hassanalian are the perfect duo to solve this problem.
As I mentioned, my area of specialty is health and safety, so
I'm doing research on drones for about 15 years.
They're designing an intrinsically safe platform and propulsion system that will be flyable and safe, something that MSHA will hopefully approve and which will enable third-party manufacturers to build drones that can be safely flown in coal mines. In December 2020, Pedram and Mostafa landed a 3-year, $600,000 research grant from the Alpha Foundation and pulled together a team. In addition to several students and researchers, it includes Dr. Jane Lair from the University of New Mexico and Dr. David Wetz from the University of Texas at Arlington. Lair and Wetz are both professors of electrical engineering. The project has 3 phases. So far, they've come up with more than 50 different configurations of what might or might not work for their design. They already know that a traditional configuration like this simple quadcopter drone won't work. They've considered adding more motors, having a coaxial configuration for each propulsion unit, or coming up with some micro-drone in the form of a monocopter that uses one motor with a larger propeller.
If we increase the number of the propeller with a smaller size, they are going to have lower efficiency than using a less number of propeller, but with a higher diameter or with different pitch angle. So
he gave you the answer.
It's obvious how passionate Mostafa and Pedram are about this project. Mostafa made sure that he showed us this.
This is something that we have multiple tracking cameras and tracking system, and this is a very safe place to test any drone that we have inside of this thing. And also for since in the underground rooms, we have ventilation, which is one of the challenges. So we are building arrays of fans so we can simulate this environment in the lab to perform this type of tests.
They'll have to figure out how their drone will fly autonomously or semi-autonomously through a dark mine with various obstacles around and not cause harm to anyone who may be working there.
This cage or this configuration that we are developing, we need to make sure that they can fly in the GPS-denied environment.
Ultimately, Pedram and Mostafa know that their platform will have to meet the strictest standards, and they remain enthusiastic about meeting the challenges.
We are working collaboratively with MSHA. They are very kind enough to give us their time and work with us on innovative approach to make the drone permissible. At the end of the day, though, we have to make sure we are going to meet all the standards and requirements that are mandated by MSHA.
We believe that we can achieve this project. We are so excited, and our students from these 3 universities are involved, and we believe that this is doable.
And we have the best team available. We are not alone. We are aware of at least two other companies, and we are working collaboratively with those companies as well, because our goal is not to make money. Our goal is to do research and advance the knowledge in the mining industry, and specifically to improve the health and safety of underground mines.
We'll keep you updated with the progress that's going on at New Mexico Tech in the coming months. Again, Pedram, Mostafa, and their team have 3 years on their research grant and some interesting challenges ahead of them. Now it's time to take a look at the new CORESafety video nugget. This one focuses on module number 14, and it's all about incident reporting and investigation. Until then, please be sure to follow our updates on Facebook and Twitter. For CORESafety and the National Mining Association, I'm Nelson Duffel. I'll see you here again next month. In the meantime, please be safe out there, and thanks for watching. Special thanks to Professors Pedram Roghanchi and Mostafa Hassanalian at New Mexico Tech for this month's interview on developing a safe propulsion system for UAVs in underground coal mines.
To share one of your safety stories, videos, or photos, email us at info@coresafetytv.org.